I'm going to be talking about deep neural networks, but the principles here would apply whatever machine learning algorithm we select. So to train a neural network model, we need a data set. And so for each data sample, we've got a specific data sample, and we've also got a label which represents the category in which that particular sample falls if we're solving a categorization problem, a classification problem. What we then do is to feed our training data into the neural network, and the neural network will make predictions. And we're then going to compare the predictions of the network with the so-called ground truth. So the ground truth with the labels associated with each of the training data samples. We feed the ground truth along with the predictions into a cost function. So initially the predictions will be really bad and the cost will be really high, and what we're going to do then is to adjust trainable parameters within our neural network in order to minimize the value of the cost function, in order to bring the predictions closer and closer to the ground truth. So that's essentially the game that we're playing as we're training any machine learning model, but in particular a neural network. It's a mathematical optimization problem to try to optimize the value of a cost function or loss function. So a neural network in particular is broken down into multiple layers, and data is typically fed in at the input layers of the network, propagates through each of the layers of the network until it gets to the output of the network where it forms a prediction. Each of the layers in the network is then composed of individual units or neurons. So if we dive down a little bit deeper into the structure of this neural network, then each individual unit or neuron in the network is performing a calculation. And in fact, each individual neuron is performing a weighted sum of all the units in the previous layer. So when we're discussing machine learning, and in fact in the Python coding examples you're going to see here during this webinar, the convention that we're using is that inputs are always going to be named X and outputs are always going to be named Y. So remember, input equals X, output equals Y in a lot of the code that we're going to see. So in this case, this particular hidden unit is performing a weighted sum of the X values, the values from the inputs here. W and B represent our weights and biases, which are trainable parameters that we're going to adjust during the training process. So each neuron performs a linear calculation followed by a non-linear part, a so-called activation function. And the commonest activation functions you'll see these days are sigmoid functions or ReLU functions. And sigmoids and ReLUs both represent threshold functions. So what happens effectively is if the weighted sum of all of the values from the previous layer exceed some threshold when adjusted by this bias, then the neuron gets triggered. And that's effectively approximating a biological neuron. So the overall deep neural network consists of multiple layers. Each individual unit here is performing a weighted sum followed by a non-linear activation function. And if our complete network contains more than one layer of hidden units, then it's known as a deep neural network. Then the outputs, the predictions of our neural network, will be compared with the ground truth in a cost function, and during the training process what we're trying to do is to minimize the value of the cost function by adjusting the values of all of these weights and biases, the trainable parameters. So the cost function is a function of all of the weights. So in this simplified diagram, we're imagining we just got two weights, W1 and W2, but in general, our cost function is going to be an n-dimensional surface in an n+1 dimensional space, where the vertical axis here, the final dimension, represents the cost or loss. And what we're trying to do as we train the network is to minimize the value of this cost function. In other words, to try to go downhill quickly, training a neural network consists in running a gradient descent algorithm where we start at some random point on this cost landscape, and what we're trying to do is find our way to a low point in the landscape, trying to find our way to the bottom of the hill. And it turns out that deep neural networks have this magical property that most of the minima turn out to be really good minima. That's just a fact that we really don't understand very well about deep neural networks. Anyway, the process of training a neural network is the process of trying to get downhill quickly to a minimum, trying to avoid and dodge all the lumps and bumps on the landscape as we get to the bottom of the landscape. And the state-of-the-art algorithms these days for training neural networks are stochastic gradient descent algorithms that involve executing this gradient descent step repeatedly over and over and over again. So this is the gradient descent update rule. On each gradient descent step, for each individual trainable parameter, each weight and bias, we're taking the old value of the weight and adjusting it a little bit, tweaking it a little bit, by taking the gradient, the slope at that point on the landscape with respect to that particular parameter, and then multiplying it by alpha, which is a learning rate. So by adjusting the learning rate, we can adjust how big a step we take downhill. And it turns out that all the state-of-the-art stochastic gradient descent algorithms actually use a separate learning rate, a different learning rate for each parameter, so a per parameter learning rate, and that learning rate is actually adaptive. It changes dynamically during the training process.
Doulos is a training company providing expertise and specialist training worldwide in all of the areas you can see on screen, from SoC design and verification, FPGA and hardware design, to embedded software and Python and deep learning. You can watch the rest of John's webinar using Python to implement a complete machine learning flow whenever you want by heading over to our website www.doulos.com/od and registering for free. For more free tips and tutorials, visit the know-how area of our website, and don't forget to subscribe to our YouTube channel. Thanks for watching.